Hello everyone. In this video, we're going to talk about the dynamo and how we can deal with it, how we can find the electromotive force which generate from it, what the meaning of some related expression such as the full cycle of alternating current, the frequency, the predictable, the effective EMF. So let's get started. Okay, first thing you have to know some related expression which help you to deal with any problem in this lesson. The full cycle of alternating current. Okay, what it mean? It means that change that happen to the alternating current during one complete turn of the dynamo coil. Okay, as you know, the dynamo coil in this case, and it's rotated between two magnetic poles like that, S and N. So as you know, it rotates, for example, in this direction. So the change which happen in direction and value in one completely cycle of the coil rotation, this is the full cycle of alternating current. So here is the change in the value by increase, then the value decrease, then the direction, okay, like that. So this called change that happens to the alternating current during one complete turn of the dynamo coil. Okay, let's move to the next. The frequency. What the meaning of frequency? Okay, I think you knew what the meaning of frequency before. Frequency mean the frequency. Sorry. Okay, frequency mean the number of cycles of AC during 1 second. Okay, and we can find it by two rules. The first one, frequency equal omega over 2 pi. We got this relation from the last session. If you remember, we said omega equal to by f, so by move 2 pi to another side, f will equal omega over 2 pi. So there are the another rule, number of rotates over time in second. Make sure that time in second, number of rotates over time in second, and make sure that you use second as a unit of the time, not the minute or hours. Okay, periodic time, the time required of dynamo coil to make completely cycle. If the dynamo coil will rotate, to complete one rotate, it takes certain time. This certain time called periodic time. Okay, this sum of related expressions, you have to understand it. You have to maybe some equation in this as right or wrong or complete or something like that. Take care that you understood it. Okay. Also, there are very important thing how we can find or how we can calculate theta. Okay, we can calculate theta. We agreed this rule in the last session. This rule comes out from if we say theta equal omega t. By substituting the value of omega, we know that omega equal to by f. So by substituting this value here, so 2 by f, and the t will remain. So theta, we can find theta with this relation to by f t, and another relation, number of rotates time 2 pi. Okay, number of rotation or number of rotates, if the equation say to you the rotates is 2 turns, so you will use number 2 times 2 pi, okay, to find the theta. Okay, but you have to understand something. when we want to find theta. Okay, okay, attention, when we want to find theta in this case and in this case, when we want to find theta. Okay, theta. Okay, we have to substitute the value of y with 180. Again, we have to substitute the value of y with 180. Why? Because we're looking for angle. We're looking for angle, and if we need to find the angle, we have to substitute the pi with 180. Anything not angle, you substitute pi with 22 over 7. Okay, we just use 180 with angles. Okay, with when the angle is a known value, as we will see in the next example. So let's move to first example and see how we can deal with it. Calculate the angle which made by Dynamo coil with magnetic flux lines after the 0.0125 of coil rotation. Know the coil makes 100 rotates at 1 second. Okay, do you please, if you can determine the givens, I think you can solve any question. But before take out the givens, let's just understand what the question meaning. Okay, if we have a coil like that, okay, a coil of unit, the coil will rotate, for example, in this direction. So after 0.00125 seconds, okay, this coil will make angle with the, okay, let me just draw the magnetic. Okay, and this is the magnetic lines. So the coil after 0.00125 second will move, so it will make angle with magnetic lines. Okay, we're looking for this angle. So let me write it after it move. For example, it will be in this case. So there are angle here. I will make it with blue between magnetic flux and the coil. Okay, we need to find this angle. Okay, now let's work on it and see how we can find it. Okay, so this is T and this is F. Because 100 rotates at 1 second, as we know, F is the number of rotates over the time in seconds. So here we have direct F. We didn't need to make any conversion. So T equal 0.00125 and F equal 100 Hz, hertz. So the rule of theta equal omega T equal 2 by F time the T time. So by substituting the value 2, okay, very good. You have to remember pi in this case, because we work on theta. Pi is 180 time 180 time frequency 100 time the time 0.00125. By using the calculator, we will find out the answer is 45 degree. Okay, thank you. That is all how we can find the unknown theta. Some related expression. You have to memorize the rules, the basic rules, which said the Emax equal NBA omega, and also you have to memorize that E equal E max sine omega t. Okay, this is the basic two rules, and this is the helpful rules that you needed. Sure, you needed to solve the problems. Thank you. That's all in this video, and in the next video we will talk about the effective EMF. Thank you. Goodbye.